We now have an example that involves time, distance, and rate. So in general, we're going to be using the formula distance equals rate times time. The only thing is we have that information for when the boat goes downstream and the return trip up the river. So I like to use a box like this to keep track of all the information. This row right here is going to be for when it goes down the river, and this row right here will be for when it goes up the river. And then divide this into pieces so that we have distance equals rate times time. And to begin with, for down the river, it goes 20 miles. So for down, the distance is 20 miles. And the time is 2 hours. Now what about the rate? Well, in the question, it's asking for the rate of the river. So we can call that R for rate, or R for river. But the boat itself has a speed. If it was on a lake and had no current to battle against or to have the current help it, then it would have its own speed, which we'll call B. So this is the speed of the boat in still water. So when we look at this part in here, there is the speed of the boat, and then the river either helps it or slows it down. Well, as it goes down the river, it takes 2 hours. The return trip up the river takes 3 hours. So in here, they're going faster, which means that the river is helping them out. So they've got their own speed plus the speed of the river. Likewise in here, for the return trip, the river is going to be slowing them down, so subtract R for the total speed. And since it says they return back to the starting point, then going back will take 20 miles. And now we can use distance equals rate times time to come up with equations from each of these rows. So 20 equals the boat plus the river times 2. And this row will give us 20 equals the boat minus the river times 3. And now we can distribute the 2, so there's going to be 2b plus 2r equals 20 for the first equation. Distribute the 3, so it's going to be 3b minus 3r equals 20. And now what I would like to do is use the elimination method. So I'm going to eliminate these two by changing them into a positive 6r and a negative 6r. In order to do that, I need to multiply the top equation by a 3 to change this into a 6r, and this needs to be multiplied by a 2. Then, for the top equation, multiply everything by a 3, so distribute. So this will be a 6b, 3 times this will be positive 6r equals, and you need to distribute over here, 3 times 20 is 60. And then for the bottom equation, distribute the 2, so this is going to be a 6b, and then a negative 6r, and a 2 times 20 is 40. And now, if you combine like terms, these are going to cancel. These will make a 12b equals 100. So the boat was traveling at 100 divided by 12 . 100 divided by 12, it's by itself it would be going 8 1/3 miles per hour. Which is wonderful, but that's not what was asked for. What was asked for was the r. So we need to go back to one of these equations and find out how much is r. So you can use any of the equations that we have that has an r in it. I think that I'll use this one. That looks to be the simplest. So now we need to find r. So in this equation, we can use 8 1/3, or I can use the 100 over 12, or I could use a improper fraction for this, which would just be this one reduced. So that's going to be 3 times 8 is 24, plus 1 makes 25, divided by 3. So using this equation, we've got 2 times b, so 2 times 25 thirds plus 2 times r equals 20. But I just noticed that this has a 2 and this has a 2 and this has a 2, so I could actually divide everything by 2 and simplify things. So divide all terms by 2, and then we're almost done. Now subtract 25 thirds from both sides, and the river is going to be 10 minus 25 thirds. So 10 minus 25 thirds, and if I want my answer to be a fraction, then just go to math, and the first one is change the answer to a fraction, 5 thirds. R equals 5 thirds, or that would be 1 2/3 miles per hour. So there is the speed of the river, 1 2/3 miles per hour.